we're going to be moving to multiplying decimals. And when we work through these types of problems, it's really important to know that what we do with the decimal place is not the same as adding and subtracting decimals, okay? And if you are willing to estimate on every problem, this is not a super tough process. If you don't estimate on every problem, you are really going to struggle. Okay, so it is required that you estimate on every single decimal problem still, even when you get comfortable with them. So, as we move to the first set of problems, which is 41 2/10 times 3 1/10, what I want to do right away is, once again, we are going to estimate on the side. Okay? Now, we're going to round this to the nearest whole number, or sometimes to 10. I'm going to show you that it doesn't always have to be the nearest whole number. I'm actually going to make this 40, just for the sake of argument. And I'm going to make this number 3. Well, 40 times 3 is 120. So we know that our answer to this problem has to be 120. Okay, now as we move to this problem, we've got to be very careful with how we line up each of these things. What I want you to do now is I want you to pretend that the decimals don't exist, okay? So we're actually, for a few minutes, going to be multiplying 412 times 31, okay? If we were multiplying 412 times 31, we would do 412 on the top of the problem and 31 on the bottom, okay? And I want you to multiply those two numbers together just like we always have before. 2 times 1 gives us 2. 1 times 1 gives us 1 in the tens place, so 110. And then 400 times 1 whole gives us 400. Okay? Now, since that number is done, we put a 0 in the tens place because we're now doing 3 tens times 2 ones, which gives us 6 tens. 3 tens times 10 tens gives us 3 hundreds. And then we have 30 times 400, which is 12 in the thousandths place. Okay? We then add these two numbers together. I'm getting a little slanted with my writing here, so I'm trying to clean that up. Our problem ends up being 12,772. But we need to reinsert our decimal. We look back at our estimation and we think to ourselves, where should the decimal go to make the most sense? So if I rewrite our problem on the side, if the decimal goes here, we are at the number 1. If it goes here, we would be near the number 12. Here would be 127. Here would be 1,277. So I'm hoping that you see that the decimal place makes the most sense to go there, because 127 would be closest to our decimal, or our estimation of 120. Okay? That's the first way that you can do these problems. The second way is we're going to go back to the original problem right here when we remove our decimals. The question is, how many places behind the decimal point does each number have? Well, 41 2/10 has 1 digit behind the decimal point, and 3 1/10 also has 1 digit behind the decimal point. Therefore, our answer should have 2 digits behind the decimal point. So when we go down to this problem, when we're looking right here on where the decimal point should go, we can look at our estimation and think, which is closest to our actual number, or we can add up the total digits behind the decimal point and make sure that our answer has 2 digits behind the decimal point as well. Okay? A lot of information there, so we're going to try one more here. 36 2/10 times 8600. Once again, we have to estimate. I'm going to do 36 times, this is closest to 1. 36 times 1 is simply 36 for our estimation. Now, we rewrite the problem without any decimals. This number had 1 digit behind the decimal point. This number had 2 digits behind the decimal point, for a total of 3 digits behind the decimal point in our answer. So now I'm going to multiply these two numbers together just like I've always done before. Now, this is going to be a little bit tougher here because these are bigger numbers. But remember, our answer has to have 3 digits behind the decimal point. 2 times 6 gives us 12 in the ones place. 6 times 6 would give us 37. Well, 36 plus 1 is 37 in the tens place. 3 times 6 is 18, plus 3 is 21 in the hundredths place. We're done with that number. We insert our 0. 80 times 2 would be 16 in the tens place. 6 times 8 plus 1 is 49. 3 times 8 would be 24, plus 4 is 28. And now we are going to add these numbers together, which gives us 13. This will be 11, 11 again, and 3. Okay, so we end up having 2 ways to figure out if we're actually on or not. We can do 3 digits behind the decimal point means that our decimal has to go here. Or we can look back at our estimation and think which of these numbers is closest to the problem we just did, and it is 31 and 132 thousandths. So that's a pretty tough problem there. And I just wanted to double check, and that is correct. When you are working on these problems, it doesn't hurt to redo them again just to make sure that you ended up getting the right answer. But remember, once again, there are 2 ways, so way 1 and way 2, to figure out where your decimal goes. Now let's work on a story problem here. The Minnesota Timberwolves, still the greatest basketball team ever created. Whoever made this problem put that in there again. Their best player is Karl Anthony Towns, and he averages 26 3/10 points per game. If there are 82 games in an NBA season, how many points did he score in the whole season? Okay, so let's try to find the important information here. I think right here, he scores this many points each game. That's really important. And then there are 82 games in an NBA season. How many points did he score in the whole season? So I feel like that's the important part of the question. This certainly seems like a multiplication problem to me. So it's going to be 26 3/10 times 82. And this time our estimation is going to be a little bit more difficult because the numbers are bigger. So what I'm going to do is try to estimate both of these into a number that has a 0 at the end of it. This is pretty close to the number 30. And this is pretty close to the number 80. Okay. Well, 30 times 80, that would be 2,400. So our answer should be around that number. Now, since our estimation was farther away from where we started, our answer is going to be a little bit further off. But the nice thing, when I multiply 263 times 82, I only removed 1 digit behind the decimal place. So that's actually not that bad at all. 3 times 2 is 6. 6 times 2 is 12. 2 times 2 is 4, plus 1 is 5. 8 times 3 is 24. 6 times 8 is 48, plus 2 is 50. 2 times 8 is 16, plus 5 is 21. All right, so now we add these together. And our decimal point, we have 1 digit behind the decimal point, so our answer will be 2,156 6/10. But it is a story problem, so we have to write out a sentence. So Karl scores, couldn't think of the word, 2,156 6/10 points per game. Now, or points in a season. Now, there's a problem with that answer. You can't score that many points, so there's 2 ways to fix this. We can either put the word about right here, so he scores about that many points in a season, or we could have rounded this to the largest whole number and made sure to put in our sentence. I like the word about. That definitely solves a lot of problems when we're working with story problems. So there we have multiplying decimals. If you have any questions, make sure you let me know.